An important context for designing critical systems is understanding the fleet exposure and probability of a loss event or mishap. In general, bigger fleets of deployed systems have a higher level of exposure to hazards. Let's take an example of the U.S. vehicle fleet, which is about 250 million vehicles, with each vehicle operated about 1 hour per day. That gives 250 million hours of exposure every single day to adverse events. Intuitively, many people think that if something happens once every million hours, it's an unlikely event. And that makes sense in everyday life because a human lifespan is less than 1 million hours. So something that happens once every million hours can be considered a once-in-a-lifetime event if it even happens at all. However, if you're producing millions of products, it's not what happens to one product that matters, but what happens to the entire fleet of products that's exposed. For the fleet of U.S. vehicles, a failure that happens once every million hours of operation will, by simple math, be happening about 250 times every single day across the operational fleet. So what's unlikely for an individual can be near certainty for a fleet of deployed systems. This is why a permissible failure rate of once every million hours is generally not acceptable for a catastrophic mishap. It is common to see much more stringent goals. The chemical process industry uses every 100 million hours for a catastrophic event. In aviation, it's every billion hours. And in rail, it's every 10 billion hours. It is important to recognize that individual hardware components tend to fail every 100,000 hours or every million hours. This is comparable to the non-fatal permissible failure rates, but is much more frequent than is permissible for life-critical failures. The only way to deal with this reality is to use independent components so that the failure of an individual component does not make the system unsafe. This means that any life-critical application, so generally speaking SIL 3 or 4, must have redundant components that fail independently and result in bringing the system to a safe state regardless of what single component within the system fails. If you have a mission-critical system and are not required to follow a safety standard, the way to look at this math is the following. Determine the fleet exposure you expect, which is simply the number of units you're going to build times the number of hours that an average unit will operate. Next, determine the number of acceptable failures at a particular level of severity. You can compute the acceptable failure rate simply by dividing the number of failures by the number of hours. Then use that number to look up in a reasonable safety standard what the SIL should be to achieve about that level of failure rates. So, for example, if you'd like your system to fail less often than every 10 million hours, you might decide to adopt IEC 61508 SIL 3, not because you're life-critical, but rather because that standard is intended to give a residual failure rate of about 10 to the 7th hours, which is your target number.